All right, let's take a look at the matter phase changes. Okay, uh, so first let's define some concepts. The first one is the boiling point. Okay, and the boiling point is the temperature at which liquid is converted to gas phase. Okay, it's a boiling point. And next is the melting point. Melting point is the temperature at which a solid is converted to a liquid phase. Um, Basically, the boiling point and the melting point depend on the strength of inner molecule forces. Okay, the stronger the inner molecule forces, the higher the boiling point and the melting point. Okay, what's the melting? Melting is the process converting a solid to liquid. Okay, melting is an endothermic process. Okay, when you melt a substance. Okay, this process absorbs heat from the surroundings. So it's the endothermic process. So the enthalpy change is a plus. Freezing is the opposite process of melting, converting a liquid to solid. Okay, this is an exothermic process. Okay. So this process actually release heat. Okay, the enthalpy change is minus. Okay, let's define a term called heat of fusion. Okay, the amount of energy required to make 1 gram of substance equals the amount of energy required to freeze 1 gram of the same substance. Okay, this called heat of fusion. Okay, this amount of energy is called heat of fusion. Okay, the unit is a calorie per gram. Okay, per gram of substance. Okay, let's take a look at the evaporation. Evaporation is the process converting a liquid to gas. Okay, it's an endothermic process. The amount of energy required to vaporize 1 gram of substance is called heat of vaporization. Okay, also it has this unit of calorie per gram of substance. The opposite process of evaporation is called condensation, converting gas to liquid. Okay, this is the isothermic process. For a given substance, amount of energy released in condensation equals the amount of energy absorbed during the evaporation. Okay, next let's take a look at the conversion between a solid phase, directly between solid phase and the gas phase. Okay, the first one is called sublimation. Sublimation is a process a solid form a gas. Okay, without passing through the liquid phase. Example is the dry ice and the solid carbon dioxide. sublines to gases carbon dioxide. It's called summation. And the opposite process is called deposition. Deposition is the reverse process of summation and converting gas to solid. Okay, that's some definitions on the matter phase changes. Next, let's take a look at the heating curve and the cooling curve. So first, let's take a look at the heating curve. Okay, and you can see this is the heating curve. Okay, let's you can see some points here: A, B, C, D, E. Okay, you can see the plateaus and the increasing lines. Okay, and the coordinates, and on the x-axis is a heat added to the system, and the y-axis is the temperature. Okay, let's start with the A point. At A point is the solid phase. Okay, is a solid phase. Then we start to add heat to the solid to the matter in solid phase. Then this solid phase temperature start to increase. Once this temperature comes to the B point, the solid phase start to melt. Okay, to become a liquid. Okay, then we continue to add heat. Then from the B point to C point, the temperature keep constant, but the melting process continues until all the solid, okay, molecules become the liquid at the C point. Okay, at the C point, and the matter completely in liquid phase. Okay, so then when we continue to heat the substance, and the temperature rises again. Okay, but in this phase, okay, the matter still matter is still in a liquid phase. Okay, this from the C to D. Okay, and the temperature increase. Okay, when the temperature reaches the D point, okay, the matter start to become gas. Okay, some liquid matter become gas. Then the temperature keep constant. Okay, although the heat continue to increase, but the temperature keep constant until to the E point. At E point, all the molecules, okay, become a gas. Okay, become gas. Okay, then they start to increase the temperature again when we add the heat. Okay, this is the heating curve. Okay, and there are two plateau here. The first one, BC, is called a melting point. Okay, the temperature is the temperature at which all the matter start to convert from the solid to liquid. Okay, the second plateau here is called a boiling point. Okay, boiling point is the temperature at which the liquid converting to gas. Okay, that's the heating curve. Okay, next let's take a look at the opposite process called the cooling curve. Okay, the same thing. You can see the coordinates is the temperature on y-axis, and the heat removed from the system is on the x-axis. Okay, generally you can see the curve is going down. We started from the gas. Okay, at this V V point. So the matter, the substance is in the gaseous state. Then we drop the temperature, okay, from the V to W, and the gas start to condense, okay, at the W point, okay. Then, although we still remove the heat, but the temperature keep constant from W to X, and from this W point, then it start to condense up to the X point. All the molecules become liquid, okay, become liquid. This is a condensation. At X point, we continue to remove the heat, drop the temperature, okay, drop the temperature, then the temperature dropped, continue to remove the heat, the temperature dropped from the X to Y until the Y point. So the matter start to become solid, okay, and continue when we continue to remove the heat, and the Y to Z point, so the temperature keep constant again, okay, and until all the molecules become the solid. Okay, at Z point, okay, all the molecules become solid. So then we continue to remove the heat, then the temperature in solid phase decrease. Okay, this is called cooling curve. All right, and this is the matter phase changes.